Hello friend, I'm Samadhi back to a new video regarding IS456-2000. Last video, I talk about 35.1 number, that's general, then talk about the different type of limit state collapse. I hope there is no doubt. If there is doubt, do comment in comment section. And in case you missed the video, then go to I section and find the last video which I uploaded the last week. So from today, we started the characteristic and design value and partial safety factor. That partial safety factor is the major difference between WSM and limit state. The major chunk of huge difference between this. So first we talk about the characteristic strength of material. Okay, that is basically design strength of every material. The term characteristic strength means that the value of strength of the material below which not more than 5% of the test result are expected to fall. Read it very carefully. Read it very carefully. Very carefully. I am again repeating. The term characteristic strength means the value of the strength of the material below which not more than 5% of the test results are expected to fail. So simple, they try to say, suppose your design strength is characteristic is M30 and you will test or you tested 100 number of cube. Okay, so if 6 number of cube is very less than 30, then your characteristic strength is not M30. But if 4 number are less than 30, that means 96 is more than 30. That means below 5% less than 30 is acceptable. So that is why they written here, they wrote there, the strength of material below which not more than 5% of test result are expected to fall. I hope that is clear. Now they are saying that the characteristic strength for concrete shall be in accordance table number 2 until the relevant Indian standard specification for reinforcing steel are modified to include the concept characteristic strength. The characteristic value shall be assumed as minimum yield stress divided by 0.2% proof stress specified in relevant Indian standard specification. Why they are saying? Because for HYSD bar, when you see their graph, there is hard to find their yield stress or design stress. That is why they are saying that minimum yield stress by divided by 0.2% of proof stress. Now we talk about the characteristic load. So first we talk about the characteristic strength. Now we talk about the characteristic load. Both are kindly same, but the conceptual they are very much different. Okay. The characteristic load means that value of load which has 95% probability of not being exceeded during the life of the structure. Since data are not available, so what means that in characteristic strength 95% 5% is not falling to the below 30. And what is the characteristic load? The characteristic load is 95% time. Suppose your design load is 1000 for your room. So 95% time maximum load less than 5% time, it may be greater than or equal to 1000. Okay. So that is why they are saying that the term characteristic load means that value of load which has a 95% probability of not being exceeded during the life of structure since data are not available. So that is why we have to, when we calculate the load, there is some IS code. For dead load it is IS 875 part 1. For imposed load, I mean to say live load, 875 part 2. Wind load are 875 part 3. Snow load 875 part 4, and seismic load IS 1893 shall be assumed as a characteristic load. So when we read about the load variation, then we'll find how to do this variation according to this code book. Okay. Now we talk about the design value. First, we talk about the material. The design strength of the material is FD, that is given by F by gamma m. What is the m? Gamma m is your partial safety factor. F is your characteristic strength of the material. So see. So why limit state is so much safe? Why? Strength of concrete is 30 in reality, but when we take this is as a design strength of this is 30 by 1.5. So definitely this value is less than 30. This 30 how came? 95% of sample is more than 30. And in design, what we say, what we assume? We assuming that these design value FD is less than 30. So practically the design strength, practically the material strength is more than 30. But we design, when we do the design, we accept it, we consider that the value is less than 30. So that the range is your factor of safety. So we take lots of factor of safety when we design. Okay, load. Now for the load, design load FD is F into gamma F. Gamma F is partial safety factor. So again I will talk in this manner. Suppose FD is a design, F is the characteristic load. Characteristic load means what? 95% time your load is not exceeded that this. Suppose so I take about 1000. 95% time this value shouldn't exceed this value. Okay. Now we multiply 1.5. So what is happening? So FD that is equal to 1500. So suppose FD is 1500 and your, say this is your 30. So how much cement concrete block is needed? Say 50. Okay. But what happened in the design? FD equal to 1500 by what is the this 30 by 1.5 design strength. Say suppose this is 25. So this value greater than 50. Actually my value is 1000, which I am increasing to 1500 by multiplying partial safety factor. Actual strength is 30, which is reduced by divided by 1.5. So that is the safe thing. That is the safe aspect between WSM and limit state method. I hope that will be clear, because that thing you never find any kind of textbook or any kind of place. If you have some doubt, definitely do comment in comment section. I will definitely get back to you. Okay. So here gamma is a partial safety factor appropriate to nature of the loading, limit state being considered. So gamma m is your partial safety factor, limit state being considered. Okay, one thing, I'll give some example again. My load is 1000 and 30 is your this. Then I need only 33 bags of cement. Say Now this 1000 is comes to 1500 and this 30 came to 25. What happened? Now we provided 60 bag of cement. In reality we will need only 33 bag cement. But when you do the design, we provide the 60 bags. So definitely in limit state method, I mean to say the design is very much safety rather than design of WSA. I hope now it will clear to you. Consequences attaining limit state. Where the consequences of structure attaining limit state are a serious nature such as the huge loss of life and disruption economy, higher value of gamma and gamma m, those given. Okay. Now we talk about the partial safety factor. The value of gamma is given table number 18. So this I will talk about you when you started the analysis. Partial safety factor gamma m material strength. Yes. 1.5 for concrete and 1.15 for steel. Why? So for concrete 1.5 and steel 1.15. Why? Concrete is your heterogeneous, where steel is homogeneous. Steel quality control in steel very much strict, whereas quality control of concrete not very much strict. That is why we take a higher factor of safety 1.5 in concrete and less factor of safety we consider in the steel. That is the main reason. We accessing the deflection, the material properties such as modulus of elasticity should be taken as those associated with the characteristic strength of the material. So this is all about the video regarding the clause number 36 where I discuss about the characteristic strength of material, then I talk about characteristic load, and I discuss about exactly what is this. Then I talk about the partial safety factor for material and partial safety factor for load. And I'm trying to draw an example for better understanding or easy understanding. And next video we'll talk about the analysis part, and then we talk about the table number 18. So I hope there is no doubt. If there is doubt, do comment in the comment section. I will definitely get back to you. If you find some value from this video, then like the video, share the video, and until see you next time, till then, bye bye, take care, and thank you for watching this video.